And there's something what we did, we said maybe this might be a first direction for the analog Intra flow, what we call also the missing link. There must be something, right? And we did a patent for that. And what it does is, there was an idea on quantum computing, but with quantum computing it's very hard to make experience because this costs a lot and you need really experienced people. So we tried to map it down to something that we can maybe have an impact on, and this is something what you see here. We built our own laptops with beamformers. Why did we do this? That was a time when we wanted to have more bandwidth out of our laptops, and this is a passive element, costs something like 30 cents. If you build this, it costs a lot of more manpower, right? The elements, it's very passive. You have here a PCMCIA card, you take the antenna cable, and you have 4 antenna elements where you can steer the beam, right? The other one is a dummy, and then there's omnidirectional just for comparison. So we had the chance to take devices and send them to different access points, for example. And then we increase the throughput. What has it to do with analog network coding? Here's the idea. Imagine you have 3 users standing in the middle of 3 base stations or access points, A, B, and C. And these base stations could talk to you. So one way of doing it is you have a beam steering that is so good that you only attach from here to C, and from here to B, and here to A. This is what they try, right? And then the capacity would be 3, so to speak. In one time slot, we can have 3 transmissions ongoing in parallel. Now, if you have an omnidirectional antenna here, then first he will send, then he will send, then he will send. So you need 3 time slots to convey your 3 packets. And this was not very interesting for us. Then we said, okay, is there another way to do this without this costly beamforming, whereas this will not work all the time? And then we said, what we could do, we turn it around. We take the beamformers on the devices, as we have done here. And we are not trying to make a beam directly to the base station. That's not what we want to do. We just say, because we are moving, we do now a beam, and just to explain you this, how does the beam work? In order to form the beam, you have to put some weights here. If they're all the same weight, it's omnidirectional, but if you have different weights, you can form any beam with a lot of these different shapes that you know of. So what we said is, we asked the base station to send their packet. So he will send packet 1, packet 2, packet 3 at the same time. So if we all listen to that, what will we hear? It's an analog version. It's an overlay of the 3 packets. Okay, then we can send it 3 times and we try to get it out, as we have learned. But what if we would now have a beamformer to this side, and to this side, directly pointing to this? Then they would send the packet, and we get 3 packets into our cooperative cluster, so we assume that later they can exchange or whatever. But now we are pointing the beams like this, as before. Nothing has changed. But the good news is you don't have to point to the base station. You can take the weight of your antenna and just make a random weight on all of the elements. Sounds familiar? Random. Not on the coding coefficient, now on the weights. And even if you move your beam, what will you see? So either you make a beam that can only get this device, or it can take 2 or all 3. It doesn't matter. Important is that you have different weights, so that plus also different directions, so to speak, so that you get different linear directions. So if he is only listening to this, he will get packet 2. If he has omnidirection, he gets a linear combination of 1, 2, and 3. So you know what this means, right? There are some options that he will get it, and then they can decode right away. But now I don't need the fine beam. I need any beam, random beam. This one here has never been implemented. The whole analog part here is a little bit stuck. We have one guy working on that. Maybe we can ask him to show you what this is. It's very tricky. And it's also hard to make traction with that. Traction means if I go to the industry and say, try this out. So they have to change their base stations with the RF baseband. Will never happen. Not with us, right? Maybe if we promise them something really big in gains, so they like more our digital way, where you can bring this in SDN and other things that's easy to realize. But it's nice to understand that there is always symmetry in life, right?